KVL and its applications. Okay, Kirchhoff's voltage law, which is a part of the subject, that is network analysis. All right, so uh, most of the topics are based on this. Okay, so we'll take this as a demo topic. Okay, all right. So if you remember, the KVL suggests the algebraic sum of the voltages around a loop is 0. Okay, so in order to apply this to any given circuit, we need to understand few things. One, I need to know how to calculate voltage across different components, and when you add the components, it should become a loop. Loop is defined as you start from a point in a circuit, you move through different components in the circuit, and you come back to the same point. Okay, if you have any such uh, connection possible, see, this is also a loop, right? This is also a loop, right? We can have any number of loops possible, right? You have to add the voltages. It is sum of voltages around a loop should be taken, and it is equal to 0 when you perform algebraic addition. So what do you mean by algebraic addition? Algebra includes plus and minus. Okay, so I have to have different voltages. Those voltages are supposed to be added or subtracted depending upon some convention. So if you want to apply this, I have to follow some convention. Okay, so in order to apply this to any circuit, first let us see what convention we are going to use. The convention to be followed. So whenever a circuit is given and my intention is to apply the KVL to that. If I want to apply KVL, I have to identify the battery, right? So this is for battery, or it's also called as a source. For source, right, the current, that is I, flows from, this is negative terminal to the positive terminal through the source. Okay, through the source, current is going to flow in this fashion. That's why this is I means it is current. Okay, so in any given circuit, how many batteries you have, you apply this first. You always start with the battery. Okay, then the second step is, this is for loads in the sense any device which is not a battery will be a load. Okay, so for loads, the same I, that is current, flows. Current is going to flow from, so current is always going to flow from positive to negative. See, its direction is reverse. Okay, so this is plus to minus through the load. Right, these 2 points are important, right? Because first I need to identify plus and minus, which terminal is plus, which terminal is minus for each and every device, right, that is present in the given circuit. That's why these two things are important. Once this is done, right, once you mark everything to a given circuit, what I can do now, I have to move around the loop in any possible direction. In the sense, you can move clockwise or anti-clockwise. So move around the loop in any possible direction. So any possible direction corresponds to clockwise or anti-clockwise, we have only two options. All right, once this is done, right, I just have to check only one thing, because my intention is to check that whether a voltage is positive or negative, because I need algebraic addition, not a simple addition. Okay, so if you want to perform a algebraic addition, right, I have to identify plus or minus. For identifying this plus or minus of a voltage, right, I am using a convention. So that's what we are discussing now. So if the voltage increases, what do you mean by increases? It is minus 2 plus, right? If it is increases, this implies that voltage is positive, right? So this is positive voltage. You put a positive sign for such voltages, okay? That is a positive voltage. Then let's say voltage decreases. So if voltage decreases, right, the decrease means it is positive to minus, plus to minus. If you see a voltage which is plus to minus, then what happens? That voltage is negative. See, the convention is going, this convention is going to generate plus or minus voltage as per our requirement. So simply add all the voltages with plus or minus sign associated with them, so that you get the actual answer, right? So the equation which the main rule we are following is this: algebraic sum of voltage around a loop is equal to 0. But in order to apply this, I have to add the voltages. When you want to add the voltage, this has to happen algebraically, because KVL statement says algebraic addition. Algebraic addition means it has to be plus or minus. To identify plus or minus, I need to follow these rules. Okay, simple rules, they are not complicated. When we solve problems, now you will understand. Okay, let's say this is what is the question, right? Quickly we'll solve two problems. So the first question is this, just to understand that, a very simple question, how to apply the KVL. Say this is 10 volts, this is 3 ohms, 5 ohms and 2 ohms. So question is to find the current in the circuit. Okay, so we have multiple options to solve, but since our intention is to learn how to apply KVL to this circuit, we'll look the answer only in terms of KVL. Okay, so let's come to the, so this is a given circuit. It's a simple circuit. Next problem will be a complicated one. Okay, so we'll come back to the convention to be followed. Look where is a battery, and for a battery, mark plus and minus, and current is going to flow from minus to plus through the source. So see, this is a battery. Battery's larger terminal is positive and this is minus. This means, according to this convention, right, we have to assume the direction of flow of current is, right, minus to plus through the battery, right? So the convention says it is minus to plus through the source. So through the source means it is going to flow through this device, in the sense the direction is bottom to upwards, upward direction, which means since the circuit is connected like this, current will flow like this, and comes back. This is the direction. So to identify the direction of flow of current, we use the first point. Okay, so that means I can mark anywhere. So you can mark a current here, or you can mark a current here as per the direction. Okay, so this is the first job for any given problem. Okay, we'll identify the direction of flow of current from the point number 1. Okay, then let's go to the point number 2. So the point number 2 says that, the second point in the convention, for load, current is going to flow from plus to minus through the load. So how many loads I have? I have 3 different loads in this given circuit, because anything which is not a source is a load. So current direction is already marked for a circuit, right? Current is always going to flow in this way only now. So if this is the direction of flow of current, use the point number 2 to mark plus and minus for the load. So load flows from plus to minus, right? So you have to mark plus and minus now looking at the direction. So through the load, this is plus, this is minus, then through the load, this direction is valid. Okay, current enters from the positive terminal, leaves from the negative terminal. So plus minus you can put for every device which is a load. Okay, for source it is minus to plus, for source it is minus to plus, for loads it is plus to minus. So marking this is my second objective for any given problem. Right. Once this is done, now you move to the next point, which says that move around the loop in any possible direction. Right. So you see, irrespective of what direction you move, you get the same answer. Okay. So let me assume that I move in this direction. I randomly chose this as a clockwise direction. Okay. We can even change. You can move the anti-clockwise. Later you can try that as a homework problem, right? Same problem, you move around anti-clockwise and you verify whether you get the same answer or not. Okay, now okay, when you move like this, now the rule comes, if the voltage increases minus to plus, then that voltage is positive. If voltage decreases, it is negative. Fine. So when I move in this fashion, I already marked the direction along which I am going to move. So you can start from one device, move around the circuit and come back to that device. That's what you mean by moving around the circuit. So I start from the battery. Through the battery, I should move in this direction. When I move in this direction, it is minus 2 plus. So initially it will be minus. When I enter the device, it is minus. When I leave the device, it is plus. Minus means it is low voltage, plus means bigger voltage. So you see voltage increases, minus to plus. So the 10 volt what I am writing here is a positive voltage. So my KVL, application of KVL is this. So minus to plus is plus 10 volts. Then I come to the next device. You have to cross the device one by one to finish the loop. When you come across the 3 ohm resistor, you can see that what happens? Initially plus, later on minus, because I am moving in this direction. Plus to minus, right? I get a plus bigger voltage first, then a lower voltage. Bigger to lower is plus to minus, it is negative. So the voltage across this 3 ohm resistor is negative, right? But what is that? 3 ohms is resistance. If you want a voltage, I need to multiply with the current flowing over there, that is I. So this is negative 3 into I. 3 into I is the voltage across 3 ohm resistor. It is negative because it is decreasing, plus to minus. Okay, once that is done, then I move to the next device. Here I am moving in this direction because anti-clockwise is that, plus to minus. So plus to minus according to our convention, that's also negative. So this is minus. Current is same current, I will flow over there. So this is 5I. Okay, then I come across the 2 ohm resistor. There also I am moving in this direction. It is plus to minus. So plus to minus, when you move, this becomes negative. So this is minus 2I. So once you reach this point, it means it is already connected to the battery. So you finished your loop is over. I started from the battery and I moved the battery. I reached the battery once again. So you finished the loop. So in a loop, the algebraic sum of the voltages should be equal to 0. So see, very simple. KVL as it is we apply, but it is in the mathematical form. Now the question is to find the current. So move all the terms containing current to the other side. So 10 is equal to minus 3 becomes plus 3 when it moves to other side. Same thing with the same thing is going to happen with the 5 and 2. So 5 plus 2 plus 3 is again 10. So this is 10I. So if you want to calculate current I, this is 10 by 10, which is 1 ampere. All right. So that is a very simple application of this. of what is called as the KVL. Okay, let's quickly go to a different question, that is okay, this is 3 volts, 8 ohms, 2 ohms, 6 ohms, and this is 12 volts. So the question is to find this current I, current flowing through the 6 ohm resistor. Again, we have multiple options to solve this, right? But as our discussion is just about KVL, let's stick to the KVL. So following the rule, mark plus and minus for batteries directly. And when I mark this, I know that current is going to flow from minus to plus. So the marking of current will be like this, because this battery supplies a current in this direction. The 3-volt battery supplies the current in this direction. So according to that, I will mark the currents. Now, since there are two different batteries, you will have two different currents. So how to identify how many currents will be there, etc. will be teaching maybe when we go through the actual subject. Okay, I1 and I2. So this I is actually equal to, because when the two currents enter from one side, it has to go from other side. So I is equal to I1 plus I2. All right. Now, since you know the currents, I can put plus minus plus minus plus minus, because current is going in this way. So for loads, current enters from plus, leaves from minus. Okay, right. Now what you want to do, you can move around the circuit in any possible direction, clockwise, anti-clockwise, you can choose. For each one you write one equation. So for the first loop, I'll write mark 1 for first loop, 2 for second loop. For the first loop, so it's I'm moving in which direction? I'm moving from this, and I'm coming back. So in this direction, I'm going to move. That's why inside the loop, I have marked clockwise in red color. So according to that, so minus to plus is plus 3 volts. Then minus plus to minus, through the 8 ohm resistor, it is 8 into I1. I1 is the current. Next, when I come to this 6 ohms, right? From when I move from top to bottom, plus to minus is minus. So resistance is 6 ohms. Current is nothing but I1 plus I2, because you see through 6 ohm resistor I have a current I1 plus I2 equals to, you finish the loop, equate to 0. So the equation becomes, I'll move the I1 and I2 to the other side just to make it positive. So 8 plus 6, this is 14 I1. Then I have minus 6 I2 goes to other side as a plus 6 I2 is equal to 3. This is equation number 1. Similarly, let's apply the KVL to the second loop. Now you see, you observe that I purposefully mark the anti-clockwise just to show that even if you go for anti-clockwise, doesn't matter, any no change. So when I move anti-clockwise for a battery, I am moving from minus to plus. So minus to plus is plus. So this is plus 12 volts. Then I have plus to minus is minus. See, 2 into I2, and it is negative because I am going to get plus first, then minus voltage. Since it is voltage is decreasing over there, it is minus 2 times I2. Then I am moving from upper side to the below, so it is plus to minus, so minus 6 times current is I1 plus I2. So that's also equal to 0, because algebraic sum of the voltage is equal to 0. So now let's write, let's bring the terms to other side. Minus 6 I1 becomes plus 6 I1. Then 6 plus 2 is 8, plus 8 I2 is equal to 12. Okay, so this is equation number 2, right? So what we can do, we can simply solve it directly by using the calculator. Okay, so let me solve this now. So just move your calculator into the equation form, and we have two unknowns. All right, so the first equation is 14i1 plus 6i2 is equal to 3, and the second equation says that 6i1 plus 8i2 is equal to 12. So it says that i1 is equal to minus 0.63 amperes. Okay, and I2 is equal to 1.97 amperes. Okay, now you see that the question here is that how much is the I is nothing but I1 plus I2. Simply add I1 plus I2 to get the answer. That is the question asked. So therefore I is equal to I1 plus I2. I1 is minus 0.63 and I2 is 1.97. Okay, so this is 1.97 minus 0.63 is nothing but 1.34 amperes.